Okay, so we know that BT is congruent with TC, right? Because this is a median, and by definition, this point T must be, hold on, this point T must be the midpoint. So we have BT is equal to CT, and if BT is equal to 10, then we have simply that TC must be equal to 10. And BC is equal to twice TC, and so that's twice 2 times 10, which is 20. Okay, so we have TC is equal to 10 and BC is equal to 20. Okay, now we have problem 3. If PT is equal to 8, then we need to find PA and TA. Okay, so this distance right here is 8, and we need to find PA and then TA, the distance of the whole thing. Okay, so 2PT is equal to PA, right? Twice this distance, PT, is going to equal the other distance. Okay, we went over that a little bit earlier in this presentation. So we have PT is 8, so 2 times 8 is equal to PA, so PA must be 16. So we have that distance 16, we have PT is equal to 8, and you know at this point I would just use the line segment addition postulate, and I would just use that TA is equal to PA plus PT. Again, this is based on the line segment addition postulate, and then I would just substitute what I know. PA again is 16, PT is 8, so 16 plus 8 is 24. TA is equal to 24. Okay, so these are the types of problems that you'll be introduced to regarding the centroid. And we have another topic in today's lecture, another point of discussion, and that is altitudes. The altitude of a triangle is the perpendicular segment from a vertex to the opposite side or the line that contains that opposite side. So let's look at this first part first. An altitude of a triangle is the perpendicular segment from a vertex to the opposite side. So if you have this triangle right here, an altitude is the perpendicular segment from this vertex dropped down perpendicular to this opposite side. Okay, so there's that perpendicular symbol. You can also think of the altitude as how tall, say for example, the trunk of your car has to be in order to accommodate this triangle. If this were the base, if PR were the base, and this was a three-dimensional figure, a three-dimensional triangle that you were trying to fit inside of the trunk of your car. So if you were trying to fit that inside the trunk of your car, then the trunk of your car would have to be that tall, at least that tall, which is the altitude of that figure in relation to this base, right? So we have also this figure, and we want to draw in an altitude that's going to be perpendicular from the vertex, okay, so perpendicular from the vertex to the opposite side. Well, here's the opposite side, but as you can see, nothing I can do would make it perpendicular. So that's why I have to go out here and make it be perpendicular to the line segment that contains that opposite side. So what that means is like that. So this then would be the height, the minimum height, the minimum height of the trunk of my car in order to accommodate this three-dimensional figure if I wanted to have PR be the base and have it stick upright inside the trunk of my car, right? So these are basically the altitudes, okay? So again, the definition of an altitude is the perpendicular segment from a vertex, in this case, here's the vertex, to the opposite side or the side containing that opposite side. It's basically how tall that object is in relation to that base. Okay? And so the question begs, are the three altitudes of a triangle concurrent? Okay, so you can try that now. You can pause this presentation here and draw yourself a triangle and draw in or construct three altitudes of a triangle and see if they're congruent. So for sake of this argument, I'll just continue myself, or rather the sake of this presentation, I'll just continue myself. I have a triangle. Again, you can pause it and just do this on your own. But here I have a triangle, and here's one altitude, right? It starts from the vertex and is perpendicular to the opposite side. Okay? I think you know what's coming next. There will be another altitude that starts from a vertex and is perpendicular to that opposite side. And then lastly, I have the last the last altitude that starts at a vertex and goes perpendicular to the opposite side. And as you can see, there is a point of concurrency. It does meet at a point. And that point of concurrency is called the orthocenter. The orthocenter has features, but you will not be responsible for them at this time. I might show you the Euler line, or we can discover the relationship between the orthocenter and the median of two different yet related triangles, or I might have you discover when an orthocenter and a centroid of a given triangle are the same point. But that will be for a later time. Again, at this time, you will not be held responsible for any features of the orthocenter. Okay, so that wraps up this lecture. If you have any questions or concerns, please feel free to contact me at your convenience, and it would be my pleasure to help you or answer any of your questions. Okay, bye-bye.